Hey guys, it's Mr. J here. Welcome back to Chem Talks. Today we're going to start our next unit, which is on solutions. And we're going to start off today by talking about different types of mixtures and then moving on to some of the basic properties of solutions. So stick with me here. A mixture is simply a combination of two or more substances that are not chemically combined. Good old trail mix here is a good example. We got M&Ms, we got peanuts, we got all different sorts of stuff that are combined, but they're not chemically mixed together. They're separate. So that's a good example of a mixture. Now, today we're going to talk about three different types of mixtures. We have suspensions, colloids, and solutions. So most of this unit is going to be spent talking about solutions. We are going to mention suspensions and colloids, which is what we'll start talking about. A suspension is a heterogeneous mixture, and what we mean by heterogeneous is that there are visibly different parts. If we look over here at the picture, we can see with this oil and water, we can see the oil, we can see the water mixed in there together. So we have visibly different parts. Okay. Example, like I said, oil and water. If we let this water sit long enough, what we're going to see is that the oil and water will separate. Okay, all mixed suspensions will eventually separate. So we have our oil up top, our water on the bottom. Why are they two different? Why is the oil on top? Remember, it's less dense than water, so it floats on it. Okay, we can also, in suspensions, filter out these different parts. We can filter off the oil and water, meaning we can separate them. Our second group we're going to talk about are what we call colloids. And colloids are, once again, they're a heterogeneous mixture, meaning there's different parts in them, but what we see is the particles are suspended rather than dissolved. So they're suspended in kind of, if we think of it like a liquid colloid, it's suspended in the liquid. Okay? But unlike the suspensions, the particles in a colloid are permanently suspended, meaning they're never going to settle out. They appear to be homogeneous the whole time, or homogeneous means they look the same throughout. Okay, and unlike suspensions, the particles cannot be filtered out. They're kind of small enough that we can't separate them. But the question is, if it's heterogeneous, then why won't these guys kind of separate? And the answer to that is what we call Brownian motion. Brownian motion results from the random movement of the particles that make up the colloidal suspension. Okay, the particles that make it up are constantly in motion, and as they move around, they're going to collide with each other. And as they have collisions, they're basically bouncing off. Okay, these collisions prevent these particles from settling out or separating, like we saw in the suspensions. Basically, this Brownian motion, it kind of prevents, we can think of it in that terms, of gravity from acting on the particles. It doesn't cause them to separate because they're constantly bumping into each other and bouncing off. Now, I don't expect you to copy this down, but please understand there's many different types of colloidal suspension. We refer to the stuff that's the main body of it as the dispersed medium. That's what's it's like the liquid part or the solid. And dispersed phase is what's being put into it. So we have a gas and liquid one, which is what whipped cream is. We put gas into cream and get whipped cream. A marshmallow. If you're sitting around a campfire roasting marshmallows, well, that's a colloidal suspension. It's a gas inside a solid. Milk and mayonnaise, those are example of two liquids being mixed together. A gas and a solid is like an aerosol, like an aerosol can of maybe hairspray or something like that. Or fog's another good example. A solid and a gas, think of smoke. We got particles of carbon being mixed with the air, it gives us that. A solid and a liquid, these could be things like egg whites, jellies, paint's a good example of this. So there's many different types of colloidal systems. The one that we are going to talk about, though, is what we call an emulsion. An emulsion is a colloidal dispersion of a liquid within a liquid. Generally, what we're going to see is these liquids do not mix well together on their own. We call that immiscible. Immiscible means the liquids generally do not mix together. And here we see salad dressing, Italian salad dressing. That's a really good example, made up of water and liquid. If you let them sit and come back, you'll notice that they separate. Well, what we can do with colloidal systems, emulsions, we can add what's called an emulsifying agent. And what the emulsifying agent does, it prevents this separating. Okay, it keeps the parts of the emulsion mixed together. Okay, it allows the formation of the colloidal dispersions of the parts of that make up the colloidal system. It keeps them mixed together. So it takes these things that are miscible or usually don't mix and allows them to mix. Couple examples. Mayonnaise is simply oil and vinegar, which generally don't mix, but we put egg yolk in that acts as our emulsifying agent, and they mix together to give us mayonnaise. Milk. Think about milk. It's made up of fat, it's made up of water, and then we put a protein in there called casein. It keeps the two of them mixed together. Another one is chocolate, made up of cocoa and sugar, and then we put another substance in and mix it together, and we get our yummy chocolate bars. So we talk about these mainly because we see these a lot. The other two classifications, we talk about aerosols a little bit, and also talk about gels like Jell-O, for example. So we take oil and vinegar, put in a little egg in there, and we end up with mayonnaise. So that's a good example of an emulsifier there, probably one of the ones you're most common with. Now, one thing that's really helpful in having a signature change, suspensions, colloid, solutions, we're going to talk about in just a minute, is what we call the Tyndall effect. And the Tyndall effect is this scattering of light caused by particles in either a suspension or colloid. Solutions will not have the Tyndall effect, will not scatter the light. So we use it to distinguish between the three types of mixtures. And what we see is that the colloids or suspension are made up of tiny particles. And as light tries to pass through them, it runs in these particles. It can't travel in a straight line. So light particle enters into these, it hits the particles and begins to spread out. It scatters the visible light stream. It kind of widens that stream. It looks something like this. We can see here we got a suspension and a colloid, and as the white light comes in, it's hitting the particles here and begins to spread out. Maybe you've seen something like this on the right-hand side when you've been sitting at home watching TV. You got light coming in through the windows, and you see these beams come down. Well, what's happened is you got dust in your air. The light hits the dust and begins to spread out. And that's what we call the Tyndall effect. So suspensions and colloids will scatter light, but solutions will not. Okay, so let's go ahead and actually talk about solutions here. So a solution, we can define it as a homogeneous mixture of two or more substances in a single physical state. And by homogeneous, kind of the opposite of heterogeneous, homogeneous means it looks the same throughout. It's a constant. It's not like we can't see the different parts as in a suspension. So it looks the same throughout. Examples that you guys can think of: salt water. Mix a little salt with water. Okay, you can't see the parts in there. Sugar water. Kool-Aid is another good example. Vinegar. Now get off the liquids, we can talk about air, right? It's a mixture of different gases. We can also have solutions that are solids, such as sterling silver, which is a mixture of different metals. So some of the properties of solutions that we want to talk about. First of all, the particles that make up solution are very small. They're much smaller than we see in either suspensions or colloids. Other thing that we notice about solutions, that the particles that make them up are spread out evenly through the entire solution. Okay, we don't find them clumped together. We find them in equally spread apart. And then finally, the particles aren't going to settle out. They're so small that the gravity really doesn't act on them, so that they stay suspended in there. So what I want you to do is, let me go through this chart with you, then pause this and copy this chart down. Now, if we look at particle size, what we see, as we just talked about, solutions are going to be the smallest, so between 0.1 to 1 nanometer. Suspensions, on the other hand, are the largest. Okay, they're 100 nanometers, which is why gravity can affect them. They're pretty big. They settle out. And then colloids are somewhere in the middle, between 1 and 100 nanometers. Now, I'm not going to expect you to be able to give me these numbers as tests, but I would like you to know that solutions are the smallest, suspensions are the biggest size particles, and colloids in the middle. Now, as we said, solutions will not filter out, suspensions will filter, and colloidal suspensions will not filter out either. They're relatively small. Solutions will not separate, suspensions will, and colloidal suspensions will not separate either. Now, effects of light, the Tyndall effect. Remember, we said solutions don't show it because the small particles are so small that they don't scatter light, but both suspensions and colloids will spread the light due to the Tyndall effect. Examples, we talked about water, salt water, soda, like pop's a good example. Suspensions can be sand and water, someplace where we can see the visual parts of it. And then colloidal systems are like milk, marshmallows, we talked about mayonnaise, fog, a bunch of different things. Okay, let's talk about some more properties of solutions. Solutions are basically made up of two parts. First one being what we call the solute. This is what is being dissolved. Generally, it's what is changing states from a solid to a liquid, perhaps. Now, if we have two liquids that mix together, the solute is going to be the one that's found in the smallest amount. Okay, so since they're both liquid, we don't really have a change of phase, but we call the one that's in the least amount, that's going to be our solute. Now, what does the dissolving? We call this the solvent. Okay, it's what's doing dissolving. Now, just because we put two things together, though, doesn't mean they're necessarily going to form a solution. Not everything dissolves. Okay, when things dissolve in each other, we call them soluble. So if two substances mix them together and they form a solution, we say they're soluble. The first substances that are capable of being dissolved. If they don't mix or are not capable of dissolving, we say they are insoluble. As we said earlier, not all solutions are in the liquid phase. We can have solid and gas. In fact, there's basically four categories that we talk about, and it's based on what is the physical state of the solvent is how we classify them. So we have our solid solutions, our gaseous solutions, liquid solutions, and then we have what we call an aqueous solution, which is a special type of liquid solution. So I want to briefly talk about each type. Our solid solution, if we have a solid and a solid, the best example of this is what we call alloys. Or alloys are simply a mixture of two or more metals. Some that you may be familiar with is something like brass. Brass is a combination of zinc and copper. Or sterling silver. That's maybe what your silverware at home is made of silver and copper. Or like 16 karat gold. It's not pure gold. It's a combination of gold, copper, and silver. So we can have a solid mixed in a solid. We can have various gaseous solutions. If we have a gas in a gas, our best example of this is our air that we breathe. It's a mixture of mainly nitrogen, oxygen, some other gas, right? About 79% oxygen, 79% nitrogen, 20% oxygen, and 1% other gases. We can also have a liquid in a gas. Best example of this is something like fog, where we have water vapor in the air. If we go to liquid solutions, we have a liquid and a liquid. Something like antifreeze, which is ethylene glycol in water, or vinegar, which is acetic acid in water. Okay. If we have a gas in a liquid, one way we measure this is dissolved oxygen in water. When they want to test the health of a stream or a lake, one of the things they look at is dissolved oxygen. So that's a good example. Seltzer water, if you ever drink seltzer water, that's an example of carbon dioxide in water. Okay, a solid in liquid. This could be something like ocean water, where we have salt water in there. Now, an aqueous solution is a special type of liquid. It's a solution where water is the solvent. Okay, so if we're going to have an aqueous, water has to be the solvent. Okay, so substances that dissolve in water are classified by whether they yield ions or molecules. So when we dissolve something in there, our solute, if it gives us ions, it's going to be one type. If it gives us molecules, it's the other. You've probably heard these terms. A substance that when it dissolves in water, if it gives us ions, we call it an electrolyte. Okay, it gives us these ions, these charged atoms. The neat thing about this is these electrolytes will conduct electricity. Now, maybe one place you've heard about electrolytes is Gatorade, right? You're working out hard, you're sweating, you're not only losing water, but you're losing ions. So Gatorade has ions, potassium, and sodium in there, and when you drink them in, it helps replenish them, so that way your body can send nerve impulses, which is simply electricity, from one nerve to the other. Now, when we put a solute in, if it dissolves but doesn't give us ions, it may form molecules. Okay, so when they form molecules, they're not going to conduct electric current very well, and we call these a non-electrolyte. Let me show you an example of what I mean here. This is an electrolyte solution. We have a light bulb, a power source, and we have two probes coming down here. When we put the probes down in an electrolyte solution, the ions are going to carry the charge from one probe to another, lighting up the light bulb. Now, if we do this with a non-electrolyte, where we have molecules rather than ions, the molecules aren't going to carry the charge. So it's not going to carry the charge from one node to the other node, and our light bulb doesn't light up. So electrolytes give us ion, they conduct electricity. Non-electrolyte solutions, they don't conduct electricity because they give us molecules. Alright guys, so today we talked about the three types of mixtures: suspensions, colloid, and solutions. We talked about the difference in properties. Will they settle, will they not settle, size of them. We talked about Brownian motion, which is why our colloidal systems look like a solution, even though they are made up of separate parts. We also talked about that we can distinguish between suspensions and colloids and solutions based on the Tyndall effect, whether or not they scatter light. Talked about different properties of solutions, such as a solvent and the solute, and we talked about electrolytes and non-electrolytes. So until next time, guys, please come see me if you have any questions, and take care. Bye.